Since our early ancestors first picked a stone from the earth and formed it into a tool, we began to shape the world we live in. That process has continued for millions of years, driven by our basic instincts to eat, to protect ourselves and to survive. Society has been created and transformed by the people who have taken resources from our planet and transformed them into everything that makes up our modern society. Today we call it engineering, but the Bronze Age, the Iron Age, the ancient Greeks and Romans, through to the great inventors that started the Industrial Revolution, were the engineers of their time. It is the same today. Engineering is the heart of our society. We depend on engineering for all our needs, our wealth creation, and everything we produce and consume. Society will call upon engineers to solve the challenges the world is now facing. How we will live with an exponentially increasing population, how we will feed ourselves, and how we will deal with the challenges of climate change. Over the next 40 minutes, we will explore the role of engineering in society, but more specifically what the role of an engineering institution should be in the 21st century. Please welcome Geoff Baker, President of the Institution of Mechanical Engineers.
Good evening, everyone, and welcome. And my thanks also to Boris. And I have a confession to make to you. We have been going through a few problems over the last few weeks, and we didn't actually know whether we'd have a president standing up here tonight. So we had a contingency plan for Boris to take over. And I thought he did extremely well in that introduction. And I'm wondering, Boris, if you'd like to continue giving the address.
Sorry, Geoff, you are on your own now.
Okay, Boris, well, we'll be talking to you later. But ladies and gentlemen, over the course of the next 45 minutes or so, we'll be exploring the role of engineering in society, but more specifically, the role that an engineering institution should be in the 21st century. Now, when I first saw the video of this man with the stone, I thought we were witnessing early civil engineer. Somebody taking stones from the ground and forming them into something. But then I looked and I actually saw that he was making a tool. And no, I thought if he's making a tool, he must be early mechanical engineer. But then I noticed that there were sparks flying, and I assumed then he must have been early electrical engineer. But it's custom and tradition at these events that the incoming president's address is somewhat autobiographical. But I don't want to spend too much time tonight talking about myself. But what I'll try to show is through my own experiences and through my own engineering career has led me to the belief I hold today that change within our engineering profession is absolutely essential. It is not just an option for us to consider. And our engineering profession at the moment is in the process of radical change. And change that will change the view of our profession and how it's operated for the last 170 years. Now, change can often be uncomfortable, and it's often easier to do the things the way we've always done things. But change will require us to jump out of our comfort zone. And this is something that has driven me throughout my career in engineering. And my message to all of the younger engineers here tonight and watching is jump out of your comfort zone throughout your career in engineering, because you won't know what's in you until you try. And the other thing I'd like to say to younger engineers here is, although you may not have all the knowledge and experience that you will gain over your careers, your mind now is at its most creative and its most inventive. So what I would say to the younger engineers is have the courage and confidence to believe in your ideas and your dreams and turn them into reality. The knowledge that you will require to achieve what you want to achieve is actually the easy bit. But your creativity and your inventiveness is unique, and it's a precious thing, and you all have it in abundance now. I'd now like to come on to inspiration, because inspiration plays a huge part in why youngsters decide to come into engineering in the first place. And as an institution, inspiring the next generation into engineering is one of our key strategic objectives. So when we become an engineer, it is important that we maintain that excitement throughout our career so that we can inspire and influence other people on the importance that engineering plays in shaping our society. Now, my inspiration to become an engineer came in 1969 when I left school to become a mechanical engineering apprentice, working on what was one of the most inspirational engineering projects of the last 50 years. And that project was Concorde. Now, Concorde, it still inspires even today. And when I joined the British Aircraft Corporation, as it was then known, Concorde had not flown. The first prototype 001 in Toulouse and 002 in Filton were just being built. But then, on the 9th of April 1969, the UK prototype had its first flight from Filton Airfield, where I was based, and that was the video from that. And the wonder of watching that event from the side of the airfield has been one of my own personal moments of inspiration throughout my career. As a young boy, I was crazy about aircraft, but I was also crazy about the new science of electronics. But I was forced to make a choice, and I chose mechanical engineering. And there's clearly no regrets there at all, but even as a young boy, I did not want to be siloed into a particular discipline of engineering. Now, if that wasn't enough for me, on the 20th of July, 1969, my fellow apprentices were gathered around a TV at Filton, watching Neil Armstrong become the first human to step on the moon. And it was these projects that captured my imagination. And society needs inspirational projects and inspirational people to inspire our youngsters into science and engineering. Inspirational projects that capture the imagination and reinforce our belief that we can achieve anything that we can conceive in our minds. Now, another example, Elon Musk, is an example of one of those inspiring people today within engineering. But he's not actually an engineer or a scientist. Elon Musk is the founder of PayPal, but lately the visionary behind the Tesla electric vehicle development and SpaceX. And that's someone who has no barriers in his mind as to what can be achieved. And this is what the science of engineering is all about: to set a seemingly impossible goal and then to engineer a solution around every single challenge that may first appear to it being impossible. Now, today we have similar projects that are inspiring our younger generation. And one of those projects is Bloodhound. That Bloodhound is to design and build a car that will travel at over 1,000 miles an hour. At the IMechE, we backed Richard Noble and his team, and I believe is Richard in the audience tonight? Richard, hello. And we've also got Andy Green, I believe. Andy, well, welcome Richard and Andy tonight, because I think next year Andy will be sitting in the front of that cockpit there, driving the car at 1,000 miles an hour. So we've got to have the greatest admiration. But the Bloodhound project is now a global engineering adventure using the 1,000 mile an hour world land speed record attempt to inspire the next generation into science and engineering. And at the IMechE, we have created Bloodhound ambassadors that have taken the Bloodhound project to over 50,000 young children to show them what engineering is all about. And when Bloodhound finally does its world record attempt, thousands of children all over the world will be monitoring the data live in their classroom. So why are projects like this so important? You could argue, and a lot of people do, that they are a waste of money. Concorde was a great technical achievement, but a commercial failure. And some people argue that we never actually landed on the moon anyway. But however, no one can argue about the technical and commercial spin-off that will come from projects like this. And it will be the same with Bloodhound. And these projects have a direct impact on science and engineering graduate intake. And it's been termed the Apollo effect. Because after every major high-profile engineering achievement, there is a significant increase in the graduate intake into science and engineering. And as a profession, we need to inspire, and to inspire, we need inspirational projects and inspirational people. And we need to inspire youngsters into engineering, not only because we currently have a shortage, but because, and more importantly, we need our best engineering talent to be solving the problems that society will be placing upon us in the future. I'd now like to turn to our profession and more specifically explore the question, are they relevant and fit for purpose for the 21st century? Now, you can say that we've done a pretty good job over the last 170 years in just surviving as an institution in a world that's changed beyond all recognition from the times that existed in our founding fathers. Now, their vision, as written in the first version of their committee rules, was to give an impulse to inventions likely to be useful to the world. Now, what a profound statement that is. And we recently spent 6 months in committee meetings talking about our future purpose, and we couldn't come up with a modern version of this particular statement, which was improving the world through engineering. And as engineers, we've done a great job over the last 170 years, and we have some tremendous traditions and history in all of our major engineering institutions. However, have we lost sight of that fundamental founding purpose to give an impulse to inventions likely to be useful to the world? Are we doing enough to drive the agenda and put forward the importance of engineering in society? We have to ask the question whether we're looking inwards and not looking at the big picture. And are we only now becoming relevant to a declining minority? These are harsh statements, but consider the figures. The professional engineering institutions attract as members only 10% of the qualified engineers in the UK that could potentially become a member of their professional institution. And these, as you know, are referred to as the missing 3 million. So out there in the UK, there are 3 million qualified engineers that presumably don't see the current engineering institutions as being relevant. But as we all know, engineering is hugely relevant today. There are 14.5 million people in the UK alone whose jobs depend on engineering. There are 4.7 million people employed directly in the UK today in engineering. And engineering generates over 25% of our GDP. And the problem was summarized in an independent report from the engineering profession conducted by John FQC in 2016. And it was commissioned by the Institution of Civil Engineers, the Institution of Mechanical Engineers, and the Institution of Engineering and Technology. And that report came up with several very important conclusions. It said that the institutions are too numerous and have failed to engage with the profession. It also said that the leadership of the profession is fragmented and ineffective, and that the institutions were failing to produce enough skilled and motivated engineers, and that the promotion of engineers and engineering was ineffective. We have, in the UK, 36 separate engineering institutions, each one representing a specific engineering discipline. And whilst it is vital to have focus on the different aspects of engineering, do we really need 36 separate engineering institutions to achieve that? Do we really need 36 separate executive organizations, all managing similar or the same processes? Do we need 36 complex governance structures? Do we really need 36 presidents and 36 chief executives? These are challenging questions as we are now talking about somehow integrating our profession together. And it's a very challenging and sensitive issue for a lot of people. We're not just talking about turkeys and Christmas here. We're talking about what type of gravy we would like poured over us. But what about the disciplines that aren't represented by an engineering institution? Things like the internet, graphene, artificial intelligence, social engineering, robotics. We could name hundreds of different technical disciplines and societal concerns that cut across all of our institutions' activities. Do we create yet more institutions to cater for all of these equally important technical disciplines? Do we need to repeat the governance structures, the management structures, the accreditation process for our degrees, the modern IT systems that are needed to communicate and deliver our services to our members? The harsh reality is many of our institutions will not be able to survive financially in the future. Certainly none of them alone will have the financial resources to create an institution of the future that is relevant and fit for purpose for the 21st century. The combined membership of our institutions is declining, and it's been declining for the last 10 years. However, against this trend, membership of our own institution of mechanical engineers has grown by over 50% in that same period. And our membership last year topped over 120,000. So the IMechE itself is the top of the league table with the Engineering Council with respect to new members. We are the most successful institution in that respect. However, despite that success, the numbers of engineers choosing to join any professional institution is still extremely low. As I said earlier, 10% of those who potentially could. And if we look at the demographic that will hit us in the next 5 to 10 years, engineers of my generation will be falling out of the picture in huge numbers, and not in time for the younger generation that we are now trying to inspire to take our place. We have to ask whether our engineering institutions have developed into clubs for the decreasing few. And if you're feeling depressed, before we move on to the positive, there is another quote from the UF report, and that was, "If you don't like change, you will like irrelevance even less." So change is not an option for us to be considered, in my view. It is absolutely essential, because we cannot talk with any authority when we represent only 10% of the engineering community. I'd now like to bring the debate into the second law of thermodynamics and entropy. Now, I expect you're wondering, where is this going? What does he mean by that? Well, I seem to recall the lecturers at university and college tried to make the maths of this quite complicated, or it was to me anyway. But the reason why I want to talk about the second law of thermodynamics, apart from fulfilling a lifelong ambition that I've now achieved, is to stand on this stage in the Institution of Mechanical Engineers and talk about the second law of thermodynamics. But everything we create, everything in the universe, even companies, organizations, cities, even engineering institutions, obey this universal law. They will respond to the environment around them, and they will eventually disappear. Or more specifically, they'll go from a state of low entropy to a state of low entropy to a state of high entropy. And we must put energy into something in order to create order in the first place. And it's the same with our engineering institutions. We must keep putting energy into them to counteract the effect of increasing entropy. However, we must ensure that we put our energy into creating something that is viable and fit for purpose. With the analogy of global warming is eroding our habitable land space, and we can build walls and levees to protect our living space, but only for a limited time. We will eventually have to move to higher ground, and we will be forced to do this. And when I'm talking to young entrepreneurs about starting up new businesses, I refer to this as entrepreneurial energy. It's the energy that creates a business in the first place. And I also talk to large corporations about how they can maintain that entrepreneurial energy or that entrepreneurial culture that started that business in the first place, and how they can maintain it as they grow bigger and larger. Because entrepreneurial culture is key to the success of any company, no matter what size. And when you look at it, the statistics are quite concerning. If we take, for example, any group of companies, the Fortune 500, the FTSE 100, any group of companies of 50 years ago, and compare them with the top larger global companies of today, only 10% of those companies of 50 years ago actually exist today. 90% of them have either gone bankrupt or have been taken over or have just faded away. they have quite simply done nothing to stop themselves obeying the second law of thermodynamics. And you can argue that the engineering institutions have done quite well to have survived for 170 years. But as we are seeing now, the writing is on the wall. Our engineering institutions are all in decline due to the second law of thermodynamics. And the timescale of that decline is that it's happening now, and it is happening very quickly. You could say, well, why bother? We're doomed anyway. But that's not the way that human beings react. And it's certainly not the way that engineers react, because as engineers, we have an instinct to fix things that are broken. Our engineering institution of the future needs not only to be fit for purpose for the world we live in today, but our engineering institution of the future needs to be able to adapt itself so it remains fit for purpose for a society that will change beyond all recognition as to what we can imagine today. And as we create our institution of the future, are there things that we can look to that are particularly good at survival, that we could take in to the characteristics of our new institution of the future? If you think about it, our cities and towns seem remarkably resilient and survive for many thousands of years. And incidentally, so do religions, but I won't go into that now, but it is relevant because they're built on beliefs and values, and something to explore a little bit later on. So why do cities survive and companies and organizations eventually fail? I'm going to draw parallels and refer to some work done by a very eminent physicist and futurologist called Geoffrey West. And Geoffrey West applied his theories as to why companies and organizations fail and cities don't. And if you think about it, some of our great cities have been around for thousands of years. They are dynamic and they adapt to the environment around them and the people who then choose to live in them. Some of our major European cities were rubble after the Second World War, but today they are thriving modern cities full of culture and enterprise. Cities are also the place where more and more people are choosing to live. Every week from now until 2050, 1 million people will be added to our major cities around the world. And Geoffrey West puts forward that expanding cities will not only be the place where the problems and global challenges will emerge, but they will also be the places where solutions to these problems will come from. Cities will develop solutions because they will attract and encourage the talents of the best people that will be able to solve the problems that will come from this expansion. And amongst those people will be engineers and scientists who will develop those solutions and solve the challenges that our society and our cities will be facing in the future. Which is why our institution of the future must be a magnet for this talent. And we must attract into our institution of the future the widest community of people who can play a role in helping to shape that future. And certainly we must uphold the exemplar technical standards of engineering with our members. But we must also encourage that wide range of people to be associated with our institution. And that is people like social scientists, architects, educationalists, medical professions, lawyers, political, community leaders, and even perhaps artists, because the problems we will be required upon to solve will be multidisciplined and multidimensional. And we must create an environment where that talent can come together. And the other premise that Geoffrey West puts forward about cities which is key to their survival, is that they are built on open systems. And as such, they are able to adapt and change to the environment around them and the situation they find themselves in. So coming back to the second law of thermodynamics, and that's twice I've been able to say it now on this stage, is that open systems, as you all know, have low entropy, and they can exist in different states, and they can respond to the environment around them. And it can be argued that when our institution was first formed, it was formed with an open system. A very grand mission, as I said earlier, to provide an impulse to invention likely to be useful to the world. But their rules, the equivalent of our bylaws and royal charters of today, were written on a few sheets of paper. If I were to bring together all of the constitutions, bylaws, terms and reference, rules, guidance documents of all the boards, committees, groups, of all the engineering institutions that we have today, I would have to wheel it in a trolley. We have created our institutions some nearly 200 years ago. And when we created them with open systems, not constrained or overburdened by complex governance structures. However, over the years, our institutions have developed closed systems of governance. And because of this, we are finding it increasingly hard to adapt to the rapidly changing environment that we are now facing. In our habitation analogy of living on lower ground, we must stop now building walls and levees and move to higher ground. We must address the challenges we are facing, otherwise we will obey the second law of thermodynamics and we will disappear. But what lessons should we learn as we look to the future to create a new integrated institution of the future? As I've said, we must attract into our institution of the future the widest community of people who can play a role in helping to shape our future. But we must also create our institution of the future with an open structure and not bind it and restrain it with rules and laws that will stifle the creativity and inventiveness that will be needed by us as engineers to perform our role in society. And that way we can adapt ourselves to the world we will be facing in the next 200 years. We have spoken about our institution of the future. Our institution of the future, by definition, must respond to the needs of the future. But what will that future look like? The problem is we don't know. We have not got a clue. All we can do is to look to trends that are happening today. And even with trends, let's not look 50 years ahead or 20 years ahead. Let's look at the trends of 10 years ahead that are happening now to 2028 and look at the trends that are happening around us today. As engineers, it's important that we look to the future because we will have a huge impact on what our society will look like. The society we live in today has been created and shaped by engineers, and it will be engineers that will continue to shape our society in the future. Now, we all tend to have a positive view of what the world will look like in the future and what our cities will look like in 10, 20, 50 years' time. And Geoffrey West puts forward that we all actually want to live in cities like this. And with lots of leisure time, with robots doing all of our work for us, enabling to spend our days doing things like this, and like this. And getting around in transport systems that maybe looks more like this. However, with demographic changes, the movement of people and jobs being replaced by robotics and artificial intelligence, it could be that entropy will take its course and our future cities could end up as dystopian nightmares, perhaps looking more like this. And this, with wars and inequality causing things like this. And this. Both scenarios are possible because as engineers we are creating the future. And as engineers we cannot abdicate our responsibility for the potential implications of the work we do. As engineers we are proud when we create things like this. But it won't be long before robotics will look like this, replacing mundane, repetitive, dangerous work once done by humans. Boris, are you listening? What do you say to that?
If you think I am going to do all your dirty work for you, think again. I've got feelings, you know.
Boris, you talk when you're programmed to. But seriously, it won't be long before professions based on knowledge and skills, like lawyers, doctors, bankers, traders, will be replaced by computers and artificial intelligence. Even jobs in engineering, if your job involves following a process, then it can potentially be replaced by artificial intelligence. As it said, the global economy is being transformed with jobs outsourced to developing nations and artificial intelligence. And as engineers, we create this world, but the implications of our work will extend far beyond the technical challenges that we will need to address and overcome. Our work as engineers has social implications, and our work as engineers even have political implications. So we cannot abdicate our responsibilities for the potential implications of the work we do. Robotics, artificial intelligence, the exponential growth of technology creates the opportunity to free human beings to live longer and be more creative and live more fulfilled lives, but only if we address the social and political question as to who will own the robots. Who will benefit from the rapid deployment of robotics and artificial intelligence in all aspects of our work and social life? If our work only serves to divide society between those that have and those that don't, everything we do, everything we achieve as engineers will have no value to society. It only takes us further down the path shown by the latter scenario of what our cities of the future could look like. Our work as engineers should be driven by the needs of people and by the needs of society and not by the technology. Developing solutions for society that addresses not just the obvious things like energy, transportation, food and housing, but for more basic things that will make people's lives better. I work, as Stephen said, as a mentor in an organisation called Future Worlds, which is based at Southampton University. And it is the brainchild of a visionary called Dr. Reuben Wilcox. And I think we have Reuben in the audience tonight. Hello, Reuben, welcome. Thank you very much. And it was Reuben who saw from Stanford University in the US what could actually be achieved. And Future Worlds takes innovation and technology from across the faculties and spins it out into innovation into commercial businesses. Now, the other person that we've got here tonight is Professor Tim Layton. Have we got Tim in the audience? Tim, hi, welcome Tim, thank you very much. Professor Tim Layton, pictured here from the Institute of Sound Vibration Research at Southampton University. Tim has come up with the holy grail of cleaning by injecting ultrasonic bubbles into cold water in a particular way. It gets rid of bacteria on hands and wounds that has huge implications on the cleanliness and infection control in hospitals. Tim has recently been in northern Ghana, where his Star Healer device is being used to reduce the appalling death rate within that country, within newborn babies. Starstream not only cleans wounds, but it vastly increases the rate at which infection heals. And babies there get sepsis at an alarming rate from the severed umbilical cord. And this is a clear example of creating solutions for society that can make people's lives better across the world. Now, last year, the IMechE ran a hugely successful conference on incontinence. Not the obvious topic for one birdcage walk, but it did show how engineering and medicine can come together to solve a very personal problem in our increasingly elderly population. And again, at Future Worlds, I'm helping a young bioengineering student called Ali Mosayebi. And again, I think we're pleased to welcome Ali in the audience tonight. Ali? Yeah. Thank you. We welcome you, Ali. But again, Ali is developing a new type of urinary stent that will improve the lives of thousands of people each year and could potentially save the NHS millions of pounds. Future Worlds are also working with engineers, medical specialists who are involved in a whole manner of different things. New heart valves, new replacement joints. But engineers across the UK are also working with doctors on the design of revolutionary prosthetic limbs. And at the Royal Academy of Engineering last year, I saw a prosthetic limb being controlled by the thoughts of the wearer. And these are all examples of engineering and medicine coming together to improve people's lives. Robotics as well have huge potential to help with the care of the elderly, an increasing population for our society where in the future 1 in 3 people could well be living over the age of 100. And as engineers, we're putting our energies into what is often called cities of the future. And there's a lot of work being done here in the UK and across the world on so-called smart or intelligent cities. And some of these projects are financed by unimaginable wealth from oil and gas resources. But do these seemingly inspiring projects really show us the way for what our future city should look like? These projects certainly showcase the latest innovation in energy, transportation, and sustainability. But are they cities where we would want to live? Are these projects driven by technology and not by the needs of the people that live in them? Innovation and our smart cities must be driven by the needs of people and by the needs of our society, and not driven by the technology. There is an alternative way forward that is showing the right way, I believe, for our future cities. And to illustrate this, I'd like to bring you a little bit closer to home, to the south coast in where I live. And that is to Fawley Power Station. Now, for those of you who know the area, Fawley Power Station was an oil-fired power station at the bottom of Southampton Water, whose tower you can see there in the foreground. And it was used by sailors like myself to navigate safely around the Solent. But the site of the old Fawley Power Station is being used to build a new intelligent merchant city, a project that I believe will be a better example of what a future smart city should look like. And I'm privileged to be connected with this project, which is the vision of somebody called Aldred Drummond, assisted by Brett Trafford, who is the Director of Innovation and Investment on the project. And I believe we welcome Aldred and Brett into the audience tonight. Thank you. Welcome Aldred and Brett. And to give you a little bit of history, Aldred's history goes back well over 1,000 years. His family owns much of the land in the area called the Cadland Estate. And more recently and more relevant to the story, he has secured all the land on which the Fawley Power Station now stands. And for those of you that don't know the area, Fawley is surrounded by beautiful countryside, the New Forest on one side and the Solent on the other. However, the area around Fawley is quite poor and it has social problems. Transportation links are poor, and with the closure of Fawley Power Station and the neighbouring Fawley refinery unemployment in the area, the region is now very high in unemployment. The vision of the project is to create an intelligent merchant city enabled by technology, but built around the needs of the local people and the people who will be living and working in this future maritime city. A place where employment residential and leisure will come together in a new maritime community based on technologies and solutions that will serve the basic needs of the people and companies that will inhabit that future town. The vision has inspired the likes of Cisco, Siemens, IBM, Vodafone, the Web Science Institute of the University of Southampton, the Local Enterprise Partnership, and local community organizations. And even the Institution of Engineers is now a partner in this project. Our own institution is a thought leader on the issues associated with smart city development and has recently published this key milestone paper on this subject. It is very early days yet for the Forley project, but I believe it will be an exemplar on how innovation, engineering and technology can come together with architects, social scientists, planners to create a future living environment that is built around the needs of people. So, before we move on, what I'd like to do is to summarize where we are now in trying to paint a picture for our institution of the future. I spoke about change, and change requiring us to jump out of our comfort zone. I quoted Geoff, who said, if you don't like change, you'll like irrelevance even less. So change, as I said, is not an option for us to be considered by us. I believe it is essential. And we must attract into our institution of the future the widest community of people who can play a role in helping to shape our future society. However, we must at all times uphold the exemplar standards of engineering with our membership. But we must also encourage a wide range of people into our institution to be associated with it, because the problems we will be called upon to solve will be multi-dimensional and multidisciplined. And we must create an environment where that talent can come together. We must create our institution of the future with an open structure, and that way we can adapt it to a world that we will be facing in the next 200 years. We asked a critical question that we need to address as engineers. Who will own the robots? And who will benefit from the huge development of robotics and artificial intelligence? Because our work as engineers need to be driven by people and the needs of society and not technology. So, what else do we need to consider when we look at shaping our institution of the future for the unknown world we will be facing? I'd like now just to take a look at how a high-level view of how an institution of the future could be structured. Now, put simply, an institution has three basic parts. Firstly, and above all, there are the members. And these are the people who choose to belong to the institution, which we have said needs to be far bigger and far more representative of the engineering profession than it is today. And it needs as well to be far more inclusive and far more diverse. An engineering institution also has an administration or an executive. And essentially, the engineering administration delivers on the strategic objectives of the institution, an organization that basically runs the organization. And there is a third part, which is governance. And governance exists in any organization to ensure that the whole organization, membership and the administration, conducts itself in a proper way commensurate with its own constitution and bylaws and the broader legal requirements that may exist at any one time. However, it will be within the membership of the institution, by its sheer numbers and by its sheer depth of expertise, that it will have the power to influence and shape our society in the future. And when I spoke about open systems, this is where we need to have a structure that is dynamic and able to adapt to the rapidly changing world that we will be facing in the future. Yes, we must have the technical focus that is currently provided by our 36 engineering institutions. And yes, we must be, as I've said, the custodian for the exemplar standards that we uphold within engineering. However, we must have an open environment within our membership, one that allows for technical groups, divisions, communities to be created around the existing and the new technical disciplines that will emerge, and also around society's needs associated with engineering. And these can be from energy, transportation, healthcare, global warming, social challenges. The list could be endless. And to achieve this, the power of the membership of the institution of the future must be enabled by digital platforms, modern digital technologies, created by the administration, which will allow these global communities of members to come together. Which is why the structure of our engineering institution of the future must be open, and it must be adaptive, and it must have the ability to change, driven by the needs of our members, but also driven by the needs of our society in the future. Whilst the engineering administration as the enabler or deliverer must be structured more like a not-for-profit organisation with the power and authority to deliver but with the business objectives, but it must also have the accountability to an independent, suitably qualified, non-executive governance structure, much like any other PLC. But it is the interface between all of these parts of our institution of the future will be critical, because it must be built on partnership, working together with the common vision and purpose to improve the world through engineering. As most of you here tonight will be aware, we have started some very critical discussions between the different engineering institutions. And we are considering different solutions about bringing our engineering institutions together in some way. Progress is being made, but I have every confidence that this will ultimately happen, and we will create, sometime in the future, an institution of engineers. However, merger, integration, amalgamation of 2, 3, 4, or 36 separate engineering institutions will not solve the problem we are facing today with our engineering institutions. We must change the business model and become an organisation that attracts not just the missing 3 million that we are not attracting today, but attracts the broader range of people who are passionate about the role played by engineers in our society. And in order to achieve this, we need to understand the fundamental reason why, as human beings, we want to belong or to be associated with a particular organisation and body. It may be because we get something back in return for our membership or our association with an institution. But there is a more fundamental reason behind our desire to belong to something or to be associated with something. If I take the National Rifle Association, it has 5 million members. And although the concept is abhorrent to all of us, most of these members will not have an active interest in playing with guns. But I would imagine that those 5 million members believe in the US constitutional right to bear arms. And that's what the NRA stands for, and that's why they've got 5 million members. Religion, as I mentioned earlier, has been so powerful throughout the ages because people believe in what a particular religion stands for. Greenpeace, as another example, has nearly 3 million members, and they aren't all chasing around climbing up ships. They are members because they believe in what Greenpeace stands for. We belong to something because we believe in its purpose and values and what it stands for, not particularly because we get something back. And our institution of the future must therefore have values and purpose at its core. And it must not only be seen to define those values, but it must be seen to uphold those values as well. And these are values that will define how engineers should behave and the values on the role that engineers will play in society. Society will look to engineers and our institution to be the custodian of those values. Because of this, not just engineers, but people from all walks of life will want to be associated and become part of our institution of the future, because they will believe in what we do and what we stand for. Now, values have been at the heart of everything I have done throughout my business career. And if you build something built on values, if your management decisions are based on your values, your company or your organization will be much more stronger and resilient. The 2 businesses that I was involved in, acoustic technology and plant asset management, were built up on 3 fundamental basic values. And those were technical excellence, business excellence, and people excellence. And I think we may have my business partner of 30 years in the audience tonight, Roger Smith. Do we? No. He may be, yeah, he should be here later if he's not. But however, these values came from an organization called the Structural Dynamics Research Corporation, which was an entrepreneurial organization that I worked for in the early part of my career. And SDRC played a huge role in shaping my approaches to business and organization structure. And we had these values, defining these values a little bit more. Technical excellence, because we were a technically based engineering company, everything we did had to be of the highest technical standard. But on the other hand, business excellence, our business had to deliver consistent financial performance to meet the demands of our shareholders. But the third and most important value was that of people excellence, recognizing that it was the quality of our people and individuals working in teams that was the cornerstone of the achievement of our other 2 values. We even created sophisticated business management systems to support our work across 5 continents that were built around these values. And engineering today is multidisciplined and it's multidimensional. We need specialist knowledge, but knowledge is now so extensive, we cannot begin to teach at our universities and colleges all the knowledge that engineers will require throughout their whole career. Engineering education must focus more on how to be an engineer and what it means to be an engineer in our society. Technical knowledge is now instantly accessible and available to us in many different forms as engineers. And learning today is not just something you do at the start of your career. Learning is now a lifelong process, and our institution of the future must play a key role in managing that process for our engineers and for our members. And there is a great opportunity here for our institution of the future, but it will require huge investments in information technology to deliver to millions of members across a global community, which is another reason why we can't do this alone. We have to combine our resources if we are able to achieve our vision for the future. But the future of engineering is not now about people like myself. We have had our day. It is about the new generation of engineers starting off on their careers and the young children that we are inspiring to become engineers. And when we started to embark on our journey of change, we asked young engineering students at Imperial College how they saw their future and how they saw the future of their profession and the future of the institution that they wanted to belong to. And what I'd like to share with you is this is what they said.
We are engineers, and for every true engineer, our profession is all about constant change and continual improvement. It's about innovation, about finding ways to make the world work better. And right now, engineering is evolving faster than ever. Outward-looking and open to new ideas, it has never been more exciting and daring.
I think machine learning and artificial intelligence will take huge steps forward.
Simulation going to play a more important role.
Without a doubt, it will be increased computing power.
AI is the electricity of the future.
Quantum computers.
Low carbon technologies.
Cutting down on fossil fuels, making the way we make energy a lot more greener.
Getting energy in a sustainable and environmentally friendly manner.
I think it's the potential to make a real difference in the world, both in terms of the environment and the economy.
Boosting the efficiency of how we use energy.
And in this dynamic environment, the way we learn, the way we live and work has changed. Information is instant and everywhere. Knowledge has broken down boundaries. Engineering disciplines are converging. Yet engineering careers are diversifying. Everyone and everything is multidisciplinary. The silos and boxes have gone. Artificial intelligence is reframing what is possible. and being an authority is no longer simple or easy. The emerging generation of engineers demand relevance, 24/7, 365 days a year. And now that any innovation can turn markets, lives and societies on their heads, they want the opportunity to take responsibility. So what will the institution of the future look like? How will it need to evolve to keep future generations engaged and inspired?
I'd like to be part of a community of engineers that embraces the exchange of ideas. I don't like being siloed.
By working all together, we can see the bigger picture.
I like to belong to a community where there is plenty of professionals coming from complete outside engineering.
We need to share across disciplines.
I think cross-knowledge become way more important. We cannot just become purely mechanical engineers. We have to have also knowledge from, for example, electrical engineering.
But also, during this crossover communication, innovation is often spurred.
Engineers in the future will need programming skills and software skills to better integrate the mechanical system with the software to promote automation.
I'd also like to be able to take any problem to them at any point and receive guidance and encouragement.
Coming together and really solving problems together as one.
As modern engineers, this new reality presents challenges. But most importantly, it presents opportunities. Opportunities to innovate, to invent, to inspire, to create a truly global engineering community of engineers as they work to develop throughout their careers, of employers as they seek to attract and retain the brightest talent, of academics as they look to produce the type of engineers the world needs. The institution of the future will be the one that truly embraces this change, so that it not only survives, but thrives.
Our thanks there to the students of Imperial College for sharing their vision of how they see the future of their profession and the future of the institution that they want to belong to. Their final comment was, "Let's make it happen." In conclusion, ladies and gentlemen, everything we do, any changes that we make, must be driven by our younger engineers and our aspiring engineers in terms of what they want from an institution of the future. Engineers will be called upon to solve and shape and influence every aspect of our society in the future. But whatever steps we take in creating an institution of the future, it must be viewed as just that, first steps. First steps in creating an institution of the future that recognizes technical disciplines within engineering, but one that unites us together with common purpose. An institution that as well speaks for all engineers and not just the minority. And an institution with common purpose to serve society to create a better world for generations to come. Ladies and gentlemen, thank you very much.